The Knack has made their return to FTC, and today we're giving you exclusive access to FTC Team 9956. Over to you, Grace.
Can you tell us a little bit about how the Knack starts their design and manufacturing process?
Sure. So our team's design methodology follows a circular pathway. We start by identifying the problem as well as the design parameters, and then we do research on previously used solutions. We brainstorm new ideas, prototype the more plausible ones, and then test them. Following that, we model a more complete design, build it, and then test that final product. And we continuously repeat this cycle until we're happy with the system.
The drivetrain is a foundational part of the robot. How did your team approach that problem this year?
So we decided to use mechanism wheels and field-centric drive to facilitate easier movement around our field. We also used Lexan for the robot because of the increase in flexibility and the lighter weight compared to sheet metal. After our most recent competition, we decided to add 3 drop wheel encoders to improve our accuracy in autonomous mode.
Intake is always a time-consuming process. Can you tell me about your mechanism?
Our goal for the intake was always to own the ring as soon as we touch them, but we aren't there yet. So for state, in our quest for continuous improvement, we added a drop-down external intake on the back of the double intake to increase the speed of pickup. The new drop-down system is driven by Polybuilt and 2 green-compliant wheels cut into spikes.
There are so many different ways to shoot the rings. Can you tell me a little bit about the Knack's mechanism?
Yeah, so our shooter is a single 4-inch flywheel with a servo that flicks the bottom ring from a stack into the flywheel. Our shooter is mounted on a pivot, and its angle is driven by a servo with a cam and a tie rod. This allows us to adjust the angle of the shooter during the match. Using a high gear ratio motor, PID loop, steel inertia wheel, and angle adjustments, our shooter can consistently shoot 3 rings in half a second.
The wall seems like a pretty difficult object to grab. How does your mechanism look?
So after 2 qualifiers, we decided our wobble arm claw was not robust enough. The new claw is a double stack comb on one side and a single straight finger. The comb shape prevents the twisting of the wobble when lifting.
In order to reach our goal in continuous improvement, we've used the mechanical addition of dead wheel encoders to make our autonomous program very consistent.
We use our new encoders to increment our feed forward to make sure that we reach our target precision with maximum precision.
With our new encoders, we were able to turn the playing field into a coordinate plane and drive to any position on the field using this coordinate system.
We also use our dead wheels to determine our angle on the field. This allows us to auto-align ourselves with the shooting towers and teleop.
Thank you, Grace. Now, the beauty of FIRST is that students learn skills beyond engineering. The Knack has dedicated hours to helping their community. Let's take a look.
We have 3 outreach goals for our team. The first outreach goal is to expand the presence of FIRST in the state of Wisconsin.
Since 2018, we have been leading the Robotics in Wisconsin campaign. Our efforts led to the doubling of the Wisconsin Competitive Robotics Grant funding. This year, we continued our Robotics in Wisconsin campaign by participating virtually on both the Wisconsin State Advocacy Planning Committee and the National Advocacy Conference Planning Committee.
We have hosted the Knack Attack qualifier 4 times at Lake Country School since 2018. Over the years, this has provided additional competition experience for about 100 teams.
Last year, we were chosen to be the Wisconsin FRC First Ladies Regional Partner. We hosted a First Ladies Lunch for about 50 girls at our 2020 qualifier with a guest panel of 3 female engineers. We also wrote a blog for the First Ladies newsletter and made bright pink First Ladies shirts and buttons. We are working with Vista volunteers to plan and host a day-long summer camp for girls at MSOE this summer.
This year, we continue to mentor younger robotics teams in our community. During our time as a team, we've provided mentoring to 7 teams in FTC and FLL in topics ranging from engineering skills to judges' presentations. In addition to mentoring this season, we helped multiple teams repair their robots at qualifiers. We've also assisted in several teams virtually this year.
Our second outreach goal is to reach out to our community, the young, the old, and those with different abilities.
In response to COVID-19, our team created an innovative patent-pending phone mount that holds a phone on top of a computer monitor to aid in telemedicine at the request of a local nurse from Aurora. Over 100 phone mounts were donated to local doctors and teachers. The project was recognized in a Forbes article and a TMJ4 news story.
Our third and final outreach goal is to grow our knowledge of STEM careers and connect with local businesses about FIRST.
At the end of last season, we sent thank you cards and a summary of our season to 14 sponsors, and recently we notified them about our qualifier. We also worked through our local Pick and Save, Chick-fil-A, and Rocky Rococo's to provide food for the qualifier. Through the phone mount project, we also connected with several businesses.
Knack!